Hello, this will be an overlook of the multiple choice questions for the AP Chapter 5 packet. Let's begin with number 1. This is a no calculator question. If I'm looking to find the integral of absolute value of x minus 1 dx, my options are hopefully to take the antiderivative, but I don't know what the antiderivative is of an absolute value function. I can make assumptions, but we're not allowed to assume. At the same time, we can't just plug the whole thing in the calculator. I would advise plugging this in the calculator just to see what the answer is, to make sure you compare it to the correct answer. So you do get D, 5/2. Let's go over how you would do this on the test. What you want to do is you want to graph this, because you have no other way of finding an antiderivative, but you know that this can be the area under the curve. Absolute value of x minus 1 is a V-shaped graph that's shifted to the right one. So if I plot this, I get this graph. It has a height of 1 at x equals 0, and it has a height of 2 at x equals 3, because it went up 1 over 1 starting from 1. So then if I calculate the area, this is a triangle with an area of 1/2. This is also a triangle with an area of 2. Add those together, 2 plus 1/2 equals your 5/2. So the answer is D. Number 2. The graph of the function f is shown below. Which of the following statements about f is false? Well, the one that is false is A. F is not continuous. I have to pick up my pencil in this location. The only way I know it's continuous is if I don't have to pick up my pencil. The values from the left and the right approach the point that is currently there. Unfortunately, they approach this hole from the left and from the right, but the actual point is higher. So that's why it's not continuous. That's why automatically this is false. As I said, since the point at A is higher than the points to the left and the right, this actually makes B true. F does have a relative maximum at x equals A. X equals A is in the domain. That's true because there's a point there. The limit from the left and the limit from the right is true because they are approaching the hole. Regardless if there's a hole there, they're approaching the same value, y value. And since D is true, that must mean E is true as well. Number 3, let f be a twice differentiable function such that f of 1 equals 2 and f of 3 equals 7. Which of the following must be true for the function f on the interval from 1 to 3? Is it true that the average rate of change of f is 5/2? Yes, because average rate of change is this. And that's 7 minus 2 over 3 minus 1, which equals 5/2. And I'm all set. So I know this one's true. Is it true that the average value of f is 9/2? Well, that would mean using the average value formula, which is 1 over 3 minus 1 times the integral of f of x dx from 1 to 3. I don't know what this equals. Nowhere in this problem am I actually able to figure out what the antiderivative of f is, nor do I know what the area of f is from 1 to 3, nor can I do anything. So this leaves me wondering. Lastly, we have the average value of f prime. That's 5/2 as well. So average value of f prime would be the same formula, except it's f prime of x. In this situation, this is actually capable of being computed. This would be 1/2 times. Now, the antiderivative of f prime is plain old f. And I'm evaluating this from 1 to 3. That's your first fundamental theorem of calculus. So if I look at this carefully, this would be 1/2 times f of 3 minus f of 1, which f of 3 minus f of 1 is 5, which ends up being 5/2. So this one's true as well. By analyzing these two statements very closely, you'll realize that they are the exact same thing. Saying the average rate of change of f, well, the average rate of change of f, the rate of change of f, is the same thing as f prime. Well, that's exactly what this is saying. The value of f prime and the rate of change of f, which is f prime, if they're the same thing, they are one and the same statement. So your answer is D. 4, this is just a review question. Given the function is defined as so, find all the values of x for which the graph of f is concave up. It's your job to get down to the second derivative. So the first derivative is this. The second derivative is this. If I set this equal to 0, I can find out that x is equal to 0 and x is equal to plus or minus root 2. I make a sign chart of the second derivative with those potential inflection points. And if I judge each zone, if I plug in values between 0 and root 2, for example 1, into the second derivative, I will get a negative number. If I plug in something bigger than root 2, for example just 2, I get a positive. And as we soon figure out, the positives occur in these zones, and that's what I want for concave up. Lastly, if f of x, the integral of f of x dx from 1 to 10 equals 4, and the integral, well, this one already I notice is backwards, so I'm going to rewrite it. The integral from 3 to 10 of f of x dx equals negative 7. Then what is the integral of f of x dx from 1 to 3? Since that's already straight from 1 to 3, I'm not going to touch it. So I know the whole area from 1 to 10 is 4. But I know that a part of that graph from 3 to 10 is negative 7. So the question is, okay, if from 3 to 10 is negative 7, then how is the whole thing 4? Only if that missing piece from 1 to 3 is 11. Because 11 plus negative 7, then it connects from 1 all the way up to 10. This will equal 4 altogether. Well, this is the piece I was looking for. So your answer is 11.